Let's go. Okay, we got a handout here. We're supposed to read the handout. Hold on to the test for class discussion at 11 a.m. Actually, it's 11:30. Be ready to answer each question in detail aloud when prompted. Now, somebody can tell me what smart junction box technology on Fords combines what?
Fuses, relays, a microcontroller, multiple circuit boards, FRET layers, and interconnection to a single integrated assembly.
Yeah, that's all good stuff, isn't it? You know how those things are put together? You might think, I'll just take this junction box apart and fix it. Well, when you start trying to take it apart, it's a dadgum laminated thing. It's so complicated, I don't know how they built it to begin with. It's got all these layers of metal and with plastic in between them and certain little tabs bent up in here, there, and yonder. It's just amazing to see it. Now this, over here somewhere, and I should have already had this, there is a smart junction box over here somewhere. This is not a smart junction box, this is a dumb junction box. Somewhere up there, there's a smart junction box, and I usually have it where I can wave it around, but it actually has got a bunch of stuff inside of it, and on the junction box, and I'll find it one of these days, and I'll show it to y'all, it's up there somewhere. It says, if you scrap, if dropped from more than 20 centimeters. Now, how much distance is 20 centimeters? It ain't very, no, 20 centimeters is about that much. Yeah, centimeters, 10 millimeters, so 20 of those, 200 millimeters is what? It's not very far. You drop it, bam, that's like 8 inches. If you drop it from 8 inches, you're supposed to replace it.
Well, that's terrible.
Yeah. Now you know these Mustangs that have the sequential tail light. Ding, 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 ding,
Yeah.
ding, ding. That's actually done by the smart junction box, and each one of those tail light segments has got a separate wire coming from it. Now back in the mid '60s, anybody that remembers that, your Thunderbirds and your Shelbys and this stuff, they had that, but they had a little relay box with some electronic junk in it that would do that in the trunk. It was back there in the trunk, so when the turn signal came back there, it would actually operate those relays in sequence inside that box in the trunk. I used to have to work on some of that stuff, but anyway, they don't do that way anymore, but what you see on the outside of the car is the same thing. And I was talking to somebody the other day about this girl coming here, and she had this Mustang, and one segment of her lights was lit up and wouldn't go off. It was, remember that? And so it was an 06 Mustang, and I said, when we looked it up, I think it was an 06, each segment of those back lights on that one, it didn't have the sequential turn signals, but each segment of the back lights had a separate wire coming out of that smart junction box. And one of them had that light lit up all the time. So I just took the bulb out of it. And I said, that driver in that junction box, I guess, is fired up all the time. She said, well, if I had to have that, what would it be? And I did some research, and it was about $400, and it'd be reprogrammed. She said, well, I guess I need to start saving up money for that. And I said, what for? You gonna spend $400 just to make that one light work when you got the other ones on that side working? I'd drive it like that. Or, splice in and let it work with the other one. Heck with that noise. I'm not spending $400 to get one of the lights to work if you got other lights on that side. Okay, Dave, the author, always begins parasitic draw testing with 4 steps. Now this guy's a pretty sharp cookie. So what do you do first when you're doing a parasitic draw test? This is kind of going back. Oh, by the way, here's the junction box that likes to get wet on the F-150s and cause all kinds of electrical gremlins. And if you ever want to know if that's what's causing it, you can bust into it right here with your screwdriver, and if you look down in there and it's all green and everything, and you can tell it's been wet, and it looks like it's, you know how that green crud when you got a bad battery that's been leaking, if water gets down in here, it'll start corroding that copper. And there's nothing in here in the way of electronics. It's just a bunch of laminated plates. Now this is not a smart junction box. This is just a junction box that had all fuses and relays in it and everything. And this one here is one like we have to replace at the Ford place, because the windshield will leak sometimes and they drip on these, and then you might have all kinds of electrical problems on that thing. But anyway, there's that thing right there. The body computer goes on the back of that one, piggyback. So you close the doors and lock them with a key fob. If the hood's open, make sure you close the latch with a screwdriver. That means click it with a screwdriver like it's closed. Now you're going to need to remember to unlock it, because you'll close the hood and it'll bounce back up. That ain't good. Make sure your underhood lamps are out. Move the keys at least 10 feet away from the car. Make sure any Bluetooth device such as a smartphone or Bluetooth headset is removed from the vehicle. Wait for a few minutes for the remaining modules to go to sleep. Now, if you close the doors and you lock them with the fob and you got the key out of it,
Still gonna keep the modules
it's
activated.
gonna go to sleep sooner that way on some of the cars. If you've still got the key in the ignition and all this, it's gonna take it longer for it to go to sleep. But if you get all of that stuff done like this, open all the doors and make sure that you've got the, you know, typically the door jar switches now are sending signals to the gem module or the body computer and telling it to turn the lights on. Well, if you take your little pocket screwdriver and latch those doors and latch the hatch and all this, you got all that stuff up, opened up just like the parasitic drain test, and you get everything latched so that it thinks all the doors closed, but they're not. You got free access to the fuse panels under the seat, if it's got those, and the ones inside the car, without opening the door and starting your process all over again. See, that's the whole deal. Now then, so you got that. You're gonna close the doors and lock them with a key fob. If the hood's open, close it and latch it. Make sure the underhood lamps are out. Now the underhood lamps. What turns on the underhood lamp?
Latch.
Is it a latch? No, it's not a latch. What's it? What is it?
A little push button sensor.
Not a push button thing. Mercury switch. In that hood light assembly on most of these vehicles, there's a mercury switch. Matter of fact, you can pull that hood down and you get it to a certain tilt angle, and that light goes out.
It's literally what I just said.
You said the push button switch.
No,
That's not a
it's
mercury
like,
switch.
The mercury switch is like what you see in thermostats and like
Yeah.
air conditioning, where you know when it gets to the other end of the contact, it turns on.
What you see, imagine a little glass bulb that's got two little pieces of wire sticking up in it and a little piece of liquid metal rolling around in there. And that liquid
It's
metal
delicious.
is the melting point's at like 21 below zero or some incredible amount, out a long way. And it rolls in there. And when it rolls over there and it goes across, it's not a push button, it's a piece of liquid metal that rolls around in there. No push button to it, that's the whole point, you know.
And mercury
That would be cool.
It sure is. The mercury's poison. If somebody gets mercury inside their car, the car is basically totaled by the insurance company if they find out about it, even if nothing else wrong with the car,
I mean,
because
I
it's
drink
that
it every
bad.
day.
Oh, heck, we used to play with it in science class, you know, put it in our hands and go back and forth. That ain't good. How are vehicle manufacturers reducing the overall, how are the, well, we got a joker over here. How many vehicle manufacturers are reducing the overall power needs of today's vehicle? I mean, how are they? How are they reducing them?
Very confused.
They're achieving this management through the use of solid-state electronic modules. Now, you're gonna see more and more and more of these modules. Well, you remember this thing I was holding in my hand the other day? This silly thing here, I talked about this in one of my war stories. It's got a passel of relays built into it. You cannot change any of those relays. You just have, of course, I know Jonathan with his penchant for, you know, making a silk purse out of a sow's ear, he's gonna get in there and figure it out. But anyway, what this is there's a bunch of relays in there and you gotta buy the whole box. It's really expensive. Well, that Hyundai up there, our Sonata, the door locks don't work on it. And if you start to digging in why the door locks aren't working, all of the relays for the door locks on that one are built inside this $700 fuse panel. And you can't change them. You just gotta put a $700 fuse panel on it. You can test them if you know which pins to operate on, and I'm gonna show you that in a minute. But anyway, that's a little picture there.
I bet you could change them with the $800 one.
Yeah, probably so. Well, it's expensive. What is an integration relay? It's basically a relay that's built onto a circuit board. Now, there were some rudimentary, do we have a car out here? There's a 97 model Mercury Sable that we work on, and you were the other day talking about that little constant control relay module.
Mm-hmm.
That's got 5 relays built into it that you can't change.
Oh yeah, I'll figure that out later after.
Yeah, they're soldered onto a board. That module is one of these kind of things. It's an integration relay. What they're doing is they build the module with all of these relays in them. Even back in the 80s, they used to have this little air conditioner controller that would operate the fan, or you know, whatever the AC would turn on, the fan would come on, and it would it did other thing with the AC, but it had a little relay built onto the board. And what I did with one time when it had kind of burned up the relay that was on the board, but nothing else was wrong with that board, I took it apart and I did a Jonathan Price thing here. What I did was I took another relay with a pigtail and soldered the wires into the places on the board and mounted that relay piggyback, and it worked forever. The only thing about it is when the fan came on, you hear it would click and make a little click noise, you know. Sold that car to my hand.
It's working.
Yeah. Oh yeah, it was, well, the fan was running too. All right, so number 4, an integration relay is actually a transistor, or more likely an integrated circuit. So what's the difference between a transistor and a relay?
integrated circuit.
One of them in his integrated circuit has no moving parts, semiconductor, 4 electrons in the valence ring. If you want to go in there small enough, you could count those, but it would be a lot of trouble. Okay. Number 5, what is the benefit of 3-prong fuses?
Provides power to 2 circuits.
Power distribution.
Provides power to 2 circuits.
Yeah, that's, I mean, well, sort of. It actually gives you, it doesn't, well, yes and no. What it's looking for is space consumption. Have you ever looked in a house fuse panel and seen that they have these little fuses that you can fit 2 little fuses in one, and where 1 fuse would ordinarily go? I use those when I build
So
mine.
tubes?
Huh?
2 fuses?
Yeah, I mean, not fuses, but I'm talking about breakers. I don't know why I
Yeah.
say fuses, yeah.
Oh, yeah.
They're those-
You know, they got 2 breakers where you could ordinarily, that's to
Yeah.
save space, and that's what these fuses are all about. And those fuses, the way that they're built on the inside, and Brian read the handout, so he knows this. The middle one's hot. And right here, you're feeding that one, and right here, you're feeding that one. See what I'm saying? So this one here in the middle, you're gonna have 3 little exposed metal pieces. That one will be hot, and you're supposed to check both sides to see if both the other ones are hot. If one side of it's blown, the fuse is junk. You gotta replace it. But it saves space, you see. They're wanting to make the fuse panel smaller, but drive even more circuits than they did before. So that halves everything. Which manufacturer's junction box may require a special relay port to remove the ECM
The
relay on?
Nissan
Yeah,
IP.
the Nissan, yeah, there you go. Here's another little fun story about relays. When Daniel Kelly was here, he had there was an Altima, and she said that, and it was cold weather, and she said when she turned on her heater, it was 5 minutes before the fan would start blowing. 5 solid minutes before the fan would start blowing. And then it would kick on and blow normally the rest of the time. And this relay was what was wrong with it. That little Nissan solid state relay got the same pinout as these other relays we use, but it's potted. And it's got a solid state components in it. And you know what Daniel did? He pulled the relay that was just exactly like it from the rear window defrost, and he put it in there, and everything was normal. He actually duplicated the problem. Turn it on, there's no fan. This relay was the issue with that. That's a $37 relay if you buy it from Nissan. A little bitty relay right there.
Did
Not a
you
part
buy
of it.
one?
Huh?
Did you buy one?
Yeah.
I didn't.
Whenever I say something about a price, they always get tickled, you know, because I'm always talking about money. But the thing about it is, I am old enough that I have had to buy a lot of stuff. And so I'm more concerned with money than these guys are, you know what I'm saying? I mean, if I've got to buy it, I want to know how much it costs.
Tell me.
Do you, when you call the parts store, do you ask them how much something is before you buy it?
Yep.
Yeah.
Price check.
I mean, I ain't got a pocket.
Whenever he needed, whenever he needed a canister purge solenoid, he was all about price. He wasn't laughing then. No, not a single chuckle came out of his mouth. Can we test this to make sure this is what it is before I go? Wow, that's $32. My goodness. All right. You can blow through it, whether it's energized or not. That means it ain't no good. When we get the new one, you can't blow through it until you energize it. I'd say that probably means it was bad. But it was costing something. All right. So let me see. Number 7. Which manufacturer's module typically has fuses but no relays?
Chrysler.
What's that Chrysler, what do they call that module?
TIPM.
TIPM, what does that stand for?
Totally integrated power module.
You go, boy. You can tell he's been in the military. He's good at abbreviations.
Hate 'em.
Acronyms. Basic use of a blank and blank or essential.
Power and ground.
Huh?
Power and ground.
No multimeter and a lab scope. Power and ground's not pretty good, but basic use. You know, power and ground are just kind of there. All right. The circuit is powered or turned on and is flowing current is the answer to number 9, which is the only time current's flowing in a circuit is when, if you turn on the switch and you got a load that's carrying current to ground, you're going to have current flowing. When using voltage drop across fuses to isolate parasitic draw, and that's what this picture's showing. How do you know which fuse is feeding the guilty circuit?
The highest drop.
Highest drop, yeah. So you basically go across every one of your fuses with your meter and look at the reading, make sure you got a good connection. When you find one fuse in that group that's drawing more current than the rest of them, that's going to be the one that's drawing. Now you're not measuring how much is going through there. All you're doing is measuring to see, because you're going to have voltage drop everywhere you got any kind of a connection at all. Unless, even on a regular piece of wire, if it's long enough, you're going to have that. All right, now then,
Virtual chart.
all right, you see right here, this is right here, that's a picture of one of those 3-prong fuses. And look at this little Toyota Lexus integration relays. It's identified by their lack of terminal numbers as well as the gray shading. If you don't have terminal numbers on the relay, and you see how those look, there's no terminal numbers on there, and so those are basically built into the box, kind of like this dadgum thing right here. And that's that 05 Crossfire. All right, so this one here is showing a voltage drop reading of 2.8 millivolts. That's with this hooked up. See, he goes across all of them, and when he finds it, the one that's drawing the most, that's the one you're going to look at first. Basically, just pinpointing the circuit is giving you the problem. Now, the problem with that is, you see these fuses like that 40 amp in the bottom left, you can't do those that way because they're covered up. So that's only good as far as you can take it.
Can't you take the little covers off of them?
You can, but I wound up busting them and they won't stay back on there. And you think kind of like I do, though, I'll tell you that. Denso and Toyota partnered to create this power management ECU that lets Toyota simplify power management systems. Plug that little thing in, and the integration relays are basically the solid state devices that take the place of 4 and 5 pin relays. A lot of times they're just a glorified transistor in there. All right, so here's your power distribution schematic. That provides a really good starting point when you're diagnosing complex power distribution system. You better be able to read this stuff. That's a simple one there, but finding out what's going on. Why do they have those little resistors wired in series with that? With those on that?
Reduce power?
No, they don't want to do that. They basically don't want it to have a any kind of a spike. You know, the clamping diode on your AC compressor clutch? It's similar to that. Huh?
I do now.
Yep. You know it now. All right, now then, here's something I want to show you that's a pretty good picture. You know what was happening here?
It's bouncing up, rubbing against there.
It was rubbing against there really hard and strong. See, it had actually dimpled this aluminum, and it rubbed into the harness, and there was copper showing there. See what I mean? So basically, this was on an F-150, and that harness was big and thick, and it was just shoved up against there. And that was causing all kinds of screwball electrical problems. You don't see stuff like that. That was something you find on a visual inspection. You could not see that unless you knew what you were looking at. You got me? This one right here is an alternator output terminal that had started developing voltage drop right here and resistance, and with all the current flowing out of that alternator, it made short shrift of this. See all this blistering, burning stuff that was going on? It has resistance, it gets hot, and begins to melt things. That's why when you put one of these terminals on an alternator, you need to make sure it's good and clean. If you make it shiny like new money, it's even better. And it wouldn't be a bad idea if you wanted to be a belt and suspenders person to go ahead and put a little bit of dielectric grease on it or something. Snug it up good and tight. Now this right here is an obvious problem, right?
Ice cream?
How would you like to have a little bite of that, you know? But here's what I wanted to point out. You see back over here, a lot of the time you'll have ground wires going through a little piggyback thing like that. That can cause your speedometer not to work, your PCM not to talk, even though the engine's running and all that kind of stuff. That's pretty interesting stuff, how that's set up. This one right here was one of my star students several years ago, and I took a picture of this, and there's a picture of it up on the wall over there. And I said, this was really not a wise thing. I like to keep those as clean as a whistle, but you'd have to replace this terminal because that's completely shot. Now, where does that come from?
A bad connection?
No. It actually comes out of the battery. A lot of times it comes out around that post. And it comes wicking up out of the battery that way, but it can get transferred basically just as vapor over there, and it starts gathering. Tell you something else, I've seen ants climb up on top of a battery and pile up from one side of the battery to the other and run the battery down. Be like a 1/4 inch thick. Ants just keep climbing up or dying, you know, and you have a bunch of dead ants. What is that?
20 amp fuse.
What's that?
The
The
battery.
battery?
Battery, what's that? What is that meaning of that? Now don't say automatic manual transactional because that ain't right.
Look at the
It's
switch.
An
showing.
alternate current path.
Oh.
When you see this little bracket, and it could go either way, if it's a manual transaction, it looks like that. If it's automatic, it looks like that. What about that right there? Why is the engine compartment fuse box a hammer on this? Represented by a box run with dotted lines, and the ignition switch is represented by a box run with solid lines.
Module?
Basically, if it's dotted lines, you're not seeing the whole thing. If it's solid, you are seeing it all. Now, this dotted line here means all these switches move together. You need to remember that, because when you get into your final exam, you're gonna be looking at some schematics, and you need to know this stuff. What's that?
Ground.
What's that? Now, don't say throttle position sensor. That's not the answer I'm looking for. What do they use for a throttle position sensor? What were you fooling with this morning on that gauge? A potentiometer, right? Potentiometer, that's what that is. That's a thermistor. Engine coolant temperature sensor. What's that?
Mercury switch.
Diode.
Oh.
That's a diode. It'll only flow current that way. It can't come back the other way. That's a gauge. What's that? That's a motor. All right, now look at this. Visual inspection. I had an alternator charging system code stored on this 2000 Focus when it was brand new. And I got under the car and I looked, and I've got this wire harness up against that EGR valve, and it's burned into it. And this is what damage it did. That one wire was breached and was touching ground, and it threw me a code for the charging system. Visual inspection is really important. Look at it before you touch it. When you see where it's touching, that's when you pull it back and you find this kind of thing. That wasn't too terribly hard to fix, but it threw a code and kept the alternator working right. This is where the short was, right here. PCM's controlling the field on that. See how that coming out there? And I drew that little circle and pointed an arrow to where the problem was. Any questions? All right. End of slideshow, click to exit. Everybody learned something on that, did you? All right.